Now we're going to look at solving radical equations. Radical equations are expressions that are underneath a radical and they're raised to an nth root equal to a number. So radical equations are underneath this radical and they're usually raised to some kind of nth root. So let's figure out how to solve radical equations. The very first thing to do is to arrange it so that one radical is isolated on one side of the equal sign. So you need to get at least one radical expression all alone with other stuff on the other side. The next thing that you want to do is raise both sides of the equation to the nth power. And that's going to eliminate your nth root. So if you are raised to the square root, you need to raise both sides to the square power, the third root to the third power, the fourth root to the fourth power, so on and so forth. After you've done that, you're going to simplify the resulting equation. If the equation still contains a radical, you're going to repeat steps A and B and do that again. If it doesn't, then you're just going to skip right to solving the equation. And the last portion, which is very important, is you have to check. You have to check your answers and make sure you get rid of any solution that doesn't work. So let's go ahead and get started by looking at example 3. Now example 3 asks us to solve the following equations. We have the square root of 2x minus 5 plus 6 equals 0. So the very first thing that I need to do is, if necessary, arrange it so one radical is isolated. Well, this is what I'm taking the square root of. Is it isolated? Well, it's not. It's got this plus 6 next to it. So what I need to do is I need to isolate it. So I need to move that 6 to the other side. So I get the square root of 2x minus 5 is equal to negative 6. Now I'm isolated, or I have a radical isolated on one side of the equal sign, because this is all alone on one side of the equal sign. B says to raise both sides to the nth power. Now, I keep calling this the square root because it has no number there. So if there is no number, that's going to equal the square root. If you have 3 in there, and that's called an index, that's your third root. 4 is your fourth root, etc. So what you do is you take a look at their index, or your n there. Well, if there is no number, that's an implied 2 for square root. So that means I need to raise both sides to the second power. So I'm doing part B, which says to raise both sides to the nth power, and that's the same as the nth root. Since it's a square root, I need to raise both sides to the second power. Now I need to do step C, which says to simplify the result. Well, the square root of 2x minus 5 squared, square root and square cancel, and I'm just left with the expression of 2x minus 5, equals negative 6 squared, which is a positive 36. Now I have to check to make sure that I don't have a radical left. Well, there's no radical left, so I can skip to step D, which tells me to solve the equation. Well, this is just a linear equation, so I need to isolate the variable. So 2x moving 5 to the other side is equal to 41. Divide both sides by 2, and x is equal to 41 over 2. The very last step tells us to check our answers. We have to check our answers because it's possible that we might have these things called extraneous solutions. So let's go ahead and check our answer to see whether or not we need to discard this. So I'm going to check x equals 41 over 2. So I'm going to plug in the x equals 41 over 2 into the equation to check. So I have the square root of 2. Instead of x, I write this 41 over 2, and then minus 5 plus 6, and I always like to put a question mark because I'm checking. I want to see if this actually equals 0. So let's go ahead and distribute here and go. Well, 2 and 41 over 2, my 2's cancel, and I'm left with the square root of 41 minus 5 plus 6, and I'm still trying to figure out if this equals 0. Well, 41 minus 5 is 36, so I get the square root of 36 plus 6, still trying to determine whether or not this is 0. Well, the square root of 36 is 6. Does 6 plus 6 equal 0? No, that's not true, which means that this guy here, this 41 over 2, is an extraneous solution, and because I have no answers left, my answer is no solution, or that empty set. So again, when you're solving a radical equation, the first thing you do is isolate one of the radicals, then you raise both sides to the nth root, which matches the index from your radical from before. Then you solve the resulting equation if there's no radicals left. For example 3, when we checked, our answer didn't work and we had to discard it. Let's look at example 4. Same thing. Step 1, make sure that you isolate your radical. Well, this is my radical. Is it all alone? No, it's got a plus x with it, so I have to move this x to the right. So I have the square root of x plus 1 is equal to 5 minus x. The next thing I need to do is I need to get rid of the radical, so I have to raise both sides to the nth power. Well, again, there's no index there, which is the square root, which means I need to square both sides or raise both sides to the second power. Right on the left, the square root of x plus 1 squared, square root and squared cancel, and I'm left with x plus 1 equals, well, 5 minus x squared, I should just write it twice to make sure I distribute correctly. So let's keep going with this. I get 5 times 5 is 25, and then I have minus 5x minus another 5x is a minus 10x, and then plus x squared. So I have x plus 1 is equal to 25 minus 10x plus x squared. Well, I don't have a radical left, and I take a look at this. The type of equation that I have left is a quadratic. Well, we solve linear equations different than we do for quadratics. Linear equations, we just isolate the variable. Quadratic equations, we have to set them equal to 0 and either use the quadratic formula or factor or complete the square. So what we need to do here first is get this thing equal to 0. So I'm going to move this x and this 1 over here to the right hand side. So cancel, cancel, I'm left with 0 is equal to 24 minus 11x plus x squared. And I don't like these things in ascending order, so I want it in descending order, so I'm just going to change the format and have it be x squared minus 11x plus 24. Now things are descending order, which is what we're most accustomed to when we factor. Well, again, this is a trinomial. Does it have a GCF? No. It's a quadratic, so I do have to factor this, or solve it by completing the square or quadratic formula or wherever your favorite method is. And I like factoring, and again, I like factoring by guess and check. So let's see what I can do here. Two things that multiply to x squared are x and x. Two things that multiply to 24 and add to a negative 11 would be a minus 3 and a minus 8. Let's check this in our heads. X squared minus 8x minus 3x gives me my negative 11x that I was looking for plus 24. Great. Set each factor equal to 0 and solve them both. I get x is equal to 3. And for my other factor, I get x is equal to 8. The very last step when you're solving radicals is that you must check. So let's go ahead and check both of these. And I'm going to start with the check of x equal 3. Again, when you check, you plug in that value back into the original equation. So in place of all the x's in your original equation. So I get the square root, and again, instead of x, I'm going to write 3 plus 1, and then it's plus x, so plus 3, and then with a question mark, does this equal 5? So again, we had this, the square root of x plus 1 plus x equals 5. So when I'm checking it, I have the square root, instead of x, I write 3 plus 1 plus 3, and we're trying to figure out if that equals 5. So let's work this out. 3 plus 1 is 4, so we have the square root of 4 plus 3, still trying to figure out if that equals 5. Well, the square root of 4 is 2. Does 2 plus 3 equal 5? Yes, it does. That means that x equal 3 checks out just fine. But I had two answers, so I have to check x equal 8. So let's go ahead and do that. So I'm going to check x equal 8. Same thing as we did before, we're going to plug it in place of all the x's in that original equation. So I have the square root of 8 plus 1 plus 8, and I'm trying to figure out, does this actually give me 5? Let's find out. Well, the square root of 8 plus 1 is the square root of 9 plus 8. Still trying to figure out, does that give me 5? Square root of 9 is 3. Does 3 plus 8 give us 5? No, it sure doesn't. So that means that we have to discard 8, and our only solution is 3. So again, when you are solving radical equations, you have to isolate one of the radicals, raise both sides to the nth power, and then simplify. As long as you don't have another radical, then you solve your equation. What you have to be careful with these radical equations is sometimes you end up with linears, sometimes you end up with quadratics, and you have to solve those appropriately. Our next video is going to deal with rational exponent equations.